Hello, my dear students. How are you all? Welcome to my channel, Maths for All. This is Sudhakar Reddy. So, as I said in the last class, in this session, we are going to discuss about areas under curves. In JEE Main, from definite integration and areas, he may ask one or two questions. So, if you watch these videos completely, you can answer you can answer the questions from different integrations as usual, areas under curves very easily. So don't miss the videos, watch completely. Let's go. So areas under the curves. So before going to discuss about the areas under the curves, I'm going to discuss the concepts briefly. How to evaluate the questions? What is the concept behind it? Let us discuss briefly. It's areas under the curve. So in areas under the curve, so tracing of a curve plays a most important role. Tracing of a curve is very important. So let us see. Suppose y is equals to f of x is curve is that y equal to f of x is a curve defined on closed interval of a comma b, closed interval of a comma b, comma the lines x is equals to a, the lines x is equals to b, and x-axis is got the area bounded by the curve y equal to f of x, the lines x is equals to a, and lines x is equal to b, and x-axis is given by. So for that, first of all, we have to find out where the curve is, whether the curve completely lies above the x-axis or the curve completely lies below the x-axis, or some part of the curve lies above the x-axis and some part of the curve lies below the x-axis. Three cases are arises when single curve is given. The curve may be lies completely above the x-axis, or the curve may be lies completely below the x-axis, or some part of the curve lies above the x-axis and some part of the curve lies below the x-axis. So here three cases arises. So the first case may be here, the first case may be like this, the second case may be like this, the third case may be like this, Here in this case, the curve y equal to f of x lies completely above the x-axis. Here the curve f of x lies completely below the x-axis. Here the some part of the curve lies above the x-axis and the some part of the curve lies below the x-axis. So in each and every case, so how do you find out the area under the curve between the lines x is equal to a and x is equals to b? So this is the line x is equals to b, x is equal to a. This is the line x is equal to b. As you all know, the line x is equal to a and x is equal to b are parallel to x-axis. So now this is the region bounded between the curve y equal to f of x and the lines x is equal to a and x is equal to b. So here the curve lies completely above the x-axis. Here the area under the curve is given as integral a to b f of x dx. Integral a to b f of x dx gives the area of this region. Now, again this is the line x is equals to a, this is the line x is equals to b, and this is the curve y equal to f of x, and this is the region bounded by the curve y equal to f of x and the lines x is equal to a and x is equals to b. Here the curve lies completely below the x-axis now. So now here the area gives y equal to minus integral a to b f of x dx. Minus integral a to b f of x dx. The curve lies below the x-axis, negative sign is must. So now here this is the line x is equals to a, this is the line x is equals to c. Sorry, x is equal to b, x is equals to b. So this is the point, this is the line x is equals to c where the curve crosses the x-axis, So in this case, this region you have to find out, this region plus this region. So now from a to c, in between a to c, the curve lies above the x-axis, in between c to b, the curve lies below the x-axis. So according to the first case, the area of this region is integral a to c f of x dx. According to second case, the area of this region is minus integral c to b f of x dx. So if you want to find out the total area, you have to add both the areas. So integral a to c f of x dx plus what is this area? Minus integral c to b f of x dx, plus into minus no. So integral c to b f of x dx. Integral c to b f of x dx. This region gives this different integration, this region gives this different integral, and this entire region gives this different integral. Integral a to c f of x dx minus integral c to b f of x dx. Here the important thing is the value of c must be lies in between a and b. The value of c must be lies in between a and b. So this is a very, very important case. In this case, three cases are there. The curve lies entirely above the x-axis, the curve lies entirely below the x-axis, if the curve, some part of the curve lies above the x-axis and some part of the curve lies below the x-axis. So these are the three different cases. So these three different cases applicable for y-axis also. So when y-axis is given, how do you find out the curve? If the curve lies right side of y-axis, and it is positive, integral a to b f of y dy. If the curve lies left side of y-axis, then the area gives minus integral a to b f of y dy, minus integral a to b f of y dy. Some part of the curve lies right side of y-axis and some part of the curve lies left side of y-axis. Then in that case, the area gives integral a to c f of y dy minus integral c to b f of y dy. Right. So this is the process when a single curve is given. This is the process when a single curve is given. So let us discuss the process when the two curves are given. So let y equal to f of x and y equal to g of x are two curves which are defined on closed interval of a comma b, and of course and the lines x is equal to a and x is equals to b. The lines x is equals to a, x is equals to b. Now let us discuss the area bounded between the two curves y equal to f of x, y equal to g of x, between the lines x is equal to a and x is equals to b. So let us discuss. Say the first case, if f of x greater than or equals to g of x. So that means when the two curves are given, first of all we have to find out which is upper curve or which is lower curve. If one is upper curve, automatically other one is lower curve. If one is lower curve, automatically other one is upper curve. So if f of x greater than or equals to g of x, for all x belongs to closed interval of a comma b, for all x belongs to closed interval of a comma b. So then in this case we can say that f of x is the upper curve and g of x is the lower curve. F of x is the upper curve and g of x is the lower curve. So in this case also, in this one also there are three different cases. Let us discuss one by one. So this is the curve y equal to f of x, this is the curve y equal to f of x, and there may be curve, this is the curve y equal to g of x, y equal to g of x. Clearly f of x greater than or equals to g of x. How can you say, sir? So for every value of x, for every value x belongs to closed interval of a comma b, clearly f of x is greater than g of x. So f of x value is more than g of x value. So that means the curve f of x must be lies above the curve g of x. And these are the two lines. This is the line x is equals to a and this is the line x is equals to b. Achha. So now the area bounded between the two curves and the lines x is equal to a and x is equals to b is this region. So this region is the area bounded between the two curves and the lines x is equal to a and x is equals to b. Suppose for example, if the two curves are like this is x-axis and this is y-axis. Now this is the curve. Now again, which is upper curve? Y equal to f of x is upper curve and y equal to g of x is lower curve. Y equal to f of x is upper curve and y equals to g of x is lower curve. And again, this is the line x is equals to a and this is the line x is equals to b, right? So this is the area bounded between the two curves, between the lines x equal to a and x equals to b. The curves may be like this. This is the line x is equals to a and this is the line x is equals to b. This is y equal to f of x and this is y equals to g of x. This is y equals to g of x. So now this is the required region. This is the required region. So once observe, in all these three cases, f of x is the upper curve, g of x is the lower curve. F of x is the upper curve, g of x is the lower curve. F of x is the upper curve, g of x is the lower curve. In all these cases, we can find out the area by using this one, area equals to, what are the lines? A to b. So integral a to b, f of x minus g of x dx. In all the cases, this region gives this different integral. This region gives this different integral. This region gives this different integral. In all the cases, integral a to b, f of x minus g of x. F of x means upper curve, minus g of x means lower curve. Upper curve minus lower curve. Upper curve minus lower curve. Very, very important. Sir, why this region gives the different integral, sir? Can you please explain, sir? So I explain briefly. I will explain briefly. Say this. In the first case, let us assume there is no second curve for some time. There is no second curve. There is only one curve, that is y equal to g of x. So the area bounded by the curve y equal to f of x and the lines x is equal to and x is equals to b is this total part, right? This total part, this entire part, this total part, according to the previous case, the total part area gives integral a to b f of x dx. This total part, integral a to b f of x dx gives this total part, this entire part. Actually. Now let us take, there is a curve y equal to g of x. No, there is a curve y equal to g of x. This is y equal to g of x. That is y equals to g of x. So now this part, see this region. So this part is the area bounded by the curve y equal to g of x between the lines x is equal to and x is equal to b. So this region gives integral a to b g of x dx. Integral a to b g of x dx. So integral a to b f of x dx gives total region, this integral a to b g of x dx, this region. But I don't want both. I don't want total region. I don't want this intersection region. I want this region only. How do you get this region? So if you subtract this part from the entire part, automatically you'll get this part now. So this entire part is nothing but integral a to b f of x dx, and this part is nothing but integral a to b g of x dx. Subtract one from other, automatically you will get this part. So the required is an integral a to b f of x minus g of x dx. F of x minus g of x dx. Sir, in this case, how do you get, sir? So now let us assume there is no f of x curve for some time. So this region, total region. Who will give this entire region? Who will give? This is the region bounded by the curve y equal to g of x and the lines x equal to a and x equal to b. But in this case, the curve lies below the x-axis now. So the entire part gives minus integral a to b g of x dx. Minus integral a to b g of x dx, this entire part, because the curve lies below the x-axis. Now there is y equal to f of x. There is y equal to f of x. Now how do you find out this part? This is the curve y equal to f of x now. That is the curve y equal to f of x. So this region gives minus integral a to b f of x dx. Minus integral a to b f of x dx. Minus integral a to b g of x dx, entire region, minus integral a to b f of x dx means this region. I don't want both, I want this. So how do you get? Subtract this from this. So total region is minus integral a to b g of x dx, and minus integral a to b f of x dx means this region. So how do you get this region? Minus integral a to b g of x dx, this is total region. From this, you have to subtract this part, so subtract minus into minus plus integral a to b f of x dx. The limits are same now. You can write it one integration, integral a to b f of x minus g of x dx. Same part. In the same region also, in this region. So in this part, how do you get this part? Only this part. So only this part, the curve lies above the x-axis. This part is integral a to b f of x dx. This part is integral a to b f of x dx. Then this part. This part is the area of the region bounded by y equal to g of x and the lines x equal to and x equal to b. So in this part, the curve lies below the x-axis. So here the region is minus integral a to b g of x dx, minus integral a to b g of x dx, plus integral a to b f of x dx, this part, minus integral a to b g of x dx, this part. Now in this case, I am going to add, I want to add. If you want the total region, you should add. Add these two, integral a to b f of x dx minus integral a to b g of x dx. Always should do upper curve minus lower curve whenever you take the x limit. If you take the y limits, same again, right curve minus left curve. Whenever you take the x limits, apply right curve minus upper curve minus lower curve. Whenever you take y limits, apply right curve minus left curve. Right curve minus left curve. This is a simple concept of areas. Okay, so let us apply the concept. Let us discuss some examples. You may ask the questions in mains like this: area of the region, area of the region, area of the region. This type of questions is asking frequently. X comma y belongs to R square such that 4x square less than or equal to y less than or equal to 8x plus 12. 4x square less than or equal to y less than or equal to 8x plus 12. So, as given that two curves, the first one is 4x square less than or equals to y, and the second one is y less than or equals to, second one is y less than or equal to 8x plus 12. First one is 4x square less than or equal to y, second one is y less than or equal to 8x plus 12. So, whenever this type of questions are given, first take the curves like this: 4x square is equals to y. Forget about the inequality for some time. Take the equality to trace the curve. So 4x square equals to y, and y is equals to 8x plus 12. Forget about the inequality. Take the equality to trace the curve. That is the first thing you should remember in this type of questions. Right. So let us draw the diagram. Let us draw the graph. Graph is mandatory to get the perfect answer. So 4x square equals to y. So for your convenience, I am going to read like this: x square equal to 1 by 4 into y. X square equal to 1 by 4 into y. In which form it is? X square equal to 4ay. X square equal to 4ay. So x square is equal to 4ay represents a parabola whose vertex is at 0, 0, and it is upwards. So the parabola should be like this. This is a parabola for x square equal to y. Now, so y equal to 8x plus 12. For your convenience, I am going to write like this: minus 8x plus y equal to 12. Minus 8x plus y equal to 12. Okay, to draw the graph, you should write like that only. To find out the area, it is enough. So minus 8x plus y equal to 12. Divide with 12. So divide with 12. That is x by minus 3 by 2. X by minus 3 by 2 plus y by 12 equals to 1. X by minus 3 by 2 plus y by 12 is equal to 1, isn't it? So that means here it is of the form x by a plus y by b equal to 1. Is of the form x by a plus y by b equals to 1. That means that line intersect the x-axis at minus 3 by 2 comma 0 and y-axis at some 12 comma 0. So that line may be like this. So no need to write the exact graph. It is enough to write the rough graph. So this is some 12, 0 comma 12. This is minus 3 comma 2. Okay. So now this is the region. This is the region bounded between the two curves. Why you said like that, sir? Let me explain. So now consider the inequality: 4x square less than or equal to y. That is 4x square minus y less than or equals to 0. Less than or equals to 0. Whenever 4x square minus y less than or equal to 0 is given, we have to consider the region which inside the parabola, which lies inside the parabola. Whenever 4x square minus y greater than or equals to 0, it may gives. So then in that case, we have to consider the region outside of the parabola. Whenever 4x square minus y less than or equal to 0, we should consider the region inside of the parabola. Whenever 4x square minus y greater than or equal to 0, it may gives. In that case, we have to consider the region outside of the parabola. So here in this case, less than or equal to 0, so we have to consider the region inside the parabola. Now y less than or equal to 8x plus 2. So y less than or equal to 8x plus 2. Whenever less than is given, it is a straight line. No, it is a straight line. Whenever less than or equal to symbol is given, you have to consider the area which lies below the line. And whenever y greater than or equal to x plus 8x plus 12 has gives, in that case we have to consider the upper part. So less than or equal to given now, lower part. Inside the region, inside the parabola, below the line. Inside the parabola, below the line. So this is the region. This is the region. So in this region here, which is the upper curve? Here the line is the upper curve. Line is the upper curve. So line is also a curve. Remember, line is also a curve. In this case, the line is the upper curve and the parabola is the lower curve. Line is the upper curve, parabola is the lower curve. So now there are no limits. So no limits. For that, you have to find out the point of intersection. The two curves intersect at this point as well as this point, right? As well as this point. The two curves intersect at 2 points. So we have to find out those 2 points. So how do you find out those 2 points? How do you solve? See, this is the value of y equal to 4x square. This is also the value of y equal to 8x plus 12. So equate those two. 4x square is equals to 8x plus 12. 4x square is equals to 8x plus 12. This is x square minus 2x minus 3 equals to 0. X square minus 2x minus 3 equal to 0. So this is x minus x square minus 3x plus x minus 3 equals to 0. So that this is x plus 1 into x minus 3 is equals to 0. X plus 1 into x minus 3 equals to 0. So here the factors are x is equals to minus 1, x is equals to 3. See, the line intersect the parabola at this point and this point. Clearly, this is x is equals to minus 1 and this is x is equals to 3. This is x is equals to 3. So that means this region is the area bounded by this line and the parabola. Between the lines x is equals to minus 1, between the lines x is equal to minus 1 and x is equals to 3. It is very clear that from the graph, so the upper curve is the line and the lower curve is the parabola. So if you don't know how to draw the graph, then it's not at all a problem. So how do you find out the lower curve and upper curve? By substituting some values without having graph. But graph is mandatory. So but if you don't know how to draw the graph, how do you find out which is lower curve and which is upper curve? So you got the limits minus 1 and 3 now. Minus 1 and 3. So take some value between minus 1 and 3. Take some value between minus 1 and 3. It is very important. 0. Very easy thing. 0 now. Substitute 0 here. X0, Y0. Substitute X0 here. Y12. If we take X is equals to 0, X0. If we take X is equal to 0 here, Y12. Here 0 we got. Here 12 we got. Which is great? 12. 12 is greater. That means this is the upper curve and this is the lower curve. Like that also we can find out lower curve and upper curve. So the required area is equals to integral minus 1 to 3. The limits are integral minus 1 to 3. Here the upper curve is 8x plus 12. Upper curve is 8x plus 12. Minus the lower curve y equal to 4x square. The lower curve y equal to 4x square. Integral minus 1 to 3, 8x plus 12 minus 4x square dx. That's it. That's it. But simple integration, a simple integration. After tracing a curve, it is very, very easy to get the answer. It's very, very simple integration. 8 into x integration x square by 2, 12 into 1 integration x, 4 into x square integration x cube. Just apply the simple limit, automatically you get the answer. So in areas, tracing of a curve plays a major role. Let us discuss one more example. A is equals to x comma y such that 0 less than or equal to y less than or equal to x into mod x plus 1, x into mod x plus 1 and minus 1 less than or equal to x less than or equal to 1. Minus 1 less than or equal to x less than or equal to 1. Yeah, 0 less than or equal to v, that means y greater than or equals to 0. Y greater than or equals to 0. That means we have to take the upper part of x-axis. From this, it is very clear that you have to take the curve which lies above the x-axis. Y greater than or equal to 0 means at above the x-axis, clearly the y value is positive. If below the x-axis, the y value is negative. So now take the curve. So y is less than or equal to x into mod x plus 1. So to trace a curve, just take the inequality. Y is equals to x into mod x plus 1. Y is equal to x into mod x plus 1, isn't it? Achha. So y is equals to x square plus 1 if x greater than 0. Y is equal to x square plus 1 if x greater than 0. Y. If x greater than 0, mod x becomes plus 6. And y is equals to minus x square plus 1. Y is equal to minus x square plus 1 if x less than 0. Y equal to minus x square plus 1 if x less than 0. Why? Mod x becomes minus x if x less than 0. Acha. So now let us try to trace the curve. At last he has given the condition minus 1 to plus 1. So he is asking the area in between minus 1 to plus 1 only. Acha. So take the first curve. Y equal to x square plus 1. So for your convenient, I am going to write here. So x square is equals to y minus 1. X square is equals to y minus 1. So this is of the form x minus h whole square is equals to 4a into y minus k. That is of the form x minus h whole square is equal to 4a into y minus k. Acha. So if the h is 0 and the k is 1, so that means h comma k is the vertex of this parabola. So what is the vertex of this parabola? h0 k1, that is 0 comma 1 is the vertex of that parabola. 0 comma 1 is the vertex of that parabola. Acha. So x quotient is positive, I mean x square is equal to plus 4a into y minus k, it is of the form plus 4a. So clearly the curve lies above, towards the curve upwards, that is upward curve. So, and the condition is x greater than 0. The condition is x greater than 0. So the curve should not lie left side of y-axis. So the vertex at 0 comma 1, vertex at 0 comma 1, and the curve upwards. So you have to take only this part. You have to take only this branch of the parabola. You should not take this branch of the parabola. Why? Because x greater than 0. X greater than 0. Now come to the second one. Y is equal to minus x square plus 1. Y equal to minus x square plus 1. So that minus x square equal to y minus 1. Minus x square equal to y minus 1. So x square is equal to minus of y minus 1. X square equal to minus of y minus 1. Again, the vertex of this parabola is same, 1 comma 0, and there is a negative sign, means the curve is downwards. Here x greater than x less than 0 means you have to take this part. So the parabola should be like this as usual. So here the parabola should be like this. This is the parabola y equal to x square plus 1, and this is the parabola minus x square plus 1. This parabola should not take on left side of y-axis. This parabola should not take on right side of y-axis, because here x greater than 0, here x less than 0. Here this is the line x equal to minus 1, and here this is the line x equals to 1. X equals to 1. So in this case he is asking this part and this part. So this is minus 1 and this is 0. So the required area is integral minus 1 to 0. Integral minus 1 to 0. In this part, which is the curve? This curve means that curve. That is minus x square plus 1 dx plus integral 0 to 1 plus integral 0 to 1 integral 0 to 1. In this case, which curve involved? X square plus 1 curve involved. So integral 0 to 1 x square plus 1 dx. See how easy it is after tracing a curve. After tracing a curve, integration is very easy. So minus 1 to 0, in this region, which curve involved? That curve. So 0 to 1, this curve involved. So integral 0 to 1 x square plus 1 dx. So that means, so to do the problems in areas, tracing of a curve is most important. Okay. Let us discuss one more question. So this type of questions he may ask frequently. Once revise all those models. Okay. The next question like this: area bounded by area bounded by y equal to x square minus 1, y equal to x square minus 1. The tangent at 2 comma 3, the tangent at 2 comma 3 to it and y-axis, everything is important. You should read the question very carefully. So area bounded by y equal to x square minus 1. The tangent at 2 comma 3. The tangent at 2 comma 3. So first of all, we should find out the equation of tangent. First curve is y equal to x square minus 1. Y equal to x square minus 1. So now equation of tangent 2 x square minus y minus 1 equal to 0, x square minus y minus 1 equal to 0, isn't it? I'm going to write it in order, x square minus y minus 1 equal to 0 at 2 comma 3. At 2 comma 3. For any curve, of course it is a parabola. For circle, for parabola, for ellipse, for hyperbola, for all the curves, the equation of tangent at a point is s1 equal to 0. Equation of tangent at the point x1 comma y1 is s1 equals to 0. So write s1 for this, xx1 minus 1 by 2 into y plus y1 minus 1 equal to 0, isn't it? xx1 minus 1 by 2 into y plus y1 minus 1 equal to 0. Here x1 means 2, this is 2x. So minus 1 by 2 into y plus y1 means 3, minus 1 equals to 0. Just take the LCM, 4x minus y minus 3 minus 2 equals to 0. Right? So what is the line there? Y equal to 4x minus 5. Y equal to 4x minus 5. This is the curve. Y equal to x square minus 1, and this is the tangent 4x minus 5. Take this minus 5 to this side. Clear or not? Okay. So now let us trace the curve. So y equal to x square minus 1. So to trace the curve, write like this. X square is equal to y plus 1. X square equal to y plus 1. So again, just now I said that this is of the form x minus h whole square equal to 4a into y minus k. Here h means 0, k means minus 1. K means minus 1. So the vertex of this parabola is 0, comma minus 1. The vertex of that parabola is 0, comma minus 1. So 0, comma minus 1 is here. 0, comma minus 1 is here. So here the quotient of x square is positive and x square equal to 4a plus 4a into y plus 1. So clearly the curve upwards. This is the curve. Achha. So now the line y equal to 4x minus 5. Y equal to 4x minus 5. So y equal to 4x minus 5. So write it in an order like this. 4x minus y equal to 5. 4x minus y equals to 5. 4x minus y equals to 5. Right? 4x minus y equal to 5. So from this is x by 5 by 4. X by 5 by 4 minus y by 5 equals to 1. Minus y by 5 equals to 1. So 5 by 4 means it is more than 1. So where it cuts the x-axis means y0. So it cuts the x-axis at minus 1 comma 0 and plus 1 comma 0. And this is 5 by 4 means more than 1. 5 by 4 means more than 1. So this parabola, it goes on like this. Draw like this parabola for our convenient. So this is 5. Let us assume. So the straight line, and this is 1 now. 5 by 4 means after 1 is there, after 1. So the straight line should be like this. At some point, it intersects the parabola. This may be the point. Okay. So now this is the region bounded between the parabola and the line and the y-axis. This is the region bounded by the parabola and the tangent and this line. So tangent at which point? This is 2 comma 3, isn't it? Tangent at which point? 2 comma 3. So this is the point 2 comma 3. Achha. This is the point 2 comma 3. So this is the line x equals to 0 and this is the line 2 comma 3. So this is the line x equals to 2. That is the line x equals to 2. So after tracing a curve, as I said, integration is very easy. Now. So integration is, this is the line x equals to 0. This is the line x is equals to 0. So integral 0 to 2. So here the upper curve. In this region, the upper curve is parabola x square minus 1. So in this region, lower curve is a straight line. There's nothing but tangent. So minus of 4x minus 5. 4x minus 5 dx. Do the integration, automatically you will get the answer. So if you apply the given property in a proper way, If you trace the curve properly, automatically it is very easy to get the 4 marks from area center curve. It is very easy to answer the question from area center curve. Okay, so keep watching. If you like the videos, so please share and don't forget to subscribe. Keep watching. We'll upload more videos. Thank you one and all. We'll meet. Bye bye.